Hello everyone. So today we're going to go over section 11.1, determining probabilities using tree diagrams and tables. So the first thing we need to talk about is what is probability? Well, probability is the chance or likelihood of an event occurring. Okay, so there is a formula that we associate with probability, specifically theoretical probability, which is that the probability of an event A is equal to the number of favorable outcomes divided by the total number of outcomes. Okay, so in this context, favorable means the outcomes that we want. And I'll give an example of that in just a moment. Okay, so here, again, specifically, this is the theoretical probability. Okay, what we put here is an event. Usually we denote it with a single letter, but sometimes you can just write the description of the event itself. Okay, so a quick example of this would be, let's say you roll a die, six-sided. Then the probability of rolling a 5 would be, well, there's one face that's a 5 on a six-sided die out of 6 different outcomes, numbers 1, 2, 3, 4, 5, and 6. Okay, so that's the simple introduction to the idea. So we'll be looking at ways to count the favorable outcomes and the total outcomes using tree diagrams and tables today. So, just a quick note, if you have multiple events, then let's say you have an event A and an event B, then the probability of both of them occurring at the same time is usually expressed as probability of A and then the and symbol B. And this is the and symbol here. So the only reason why I write this here is because this is in the book. Okay, but usually we tend to use the notation to the right, this one right here. All right, so probability, as you saw in the example, that was a fraction. We can also express it as decimals and as percents. Okay, so we already did this one, probability of rolling a 5 on a six-sided die. If it doesn't specify what kind of dice we're using, then it's just going to be a six-sided die. So this will be 1 out of 6. Flip a coin and getting heads, that would be 1 in 2, right? Because it's either heads or tails. Probability of choosing a heart from a deck of cards. So if you just randomly choose one card, well, there are 13 hearts in the deck of cards out of 52 cards. So that could be reduced to 1 out of 4, which makes sense because there are 4 different suits, spades, hearts, clubs, and diamonds, and each one has 13 cards. All right. So what if you're not familiar with the number of outcomes or which ones are favorable? Then sometimes what you want to do is list a sample space. Okay, so sample space is a list of all possible outcomes for a probability experiment. Okay, let's see how to write some sample space. Okay, again, we're going to start with something more familiar. What is the sample space of rolling a die? Well, that would simply be the numbers 1, 2, 3, 4, 5, and 6. And that's it. So that's all you need to write. What if you are tossing 2 coins? Well, then there are actually 4 possibilities. You can get heads, 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 tails, tails, heads, and finally tails, tails. If you add a third coin, then there will be 8 outcomes, and we'll talk about this more in the next lesson. Next one, independent events, a very important concept in the study of probability. These are events where the outcomes or the outcome of one event does not affect another. Okay, so for example, you can flip a coin, and then if you flip the same coin again, the outcome of the first flip is not going to affect what the second one is going to be. Okay, let's move on to the tree diagram. We're going to use tree diagrams to list sample space if we have a few different events that are independent of each other happening together. So in this case, you can see on the left we have a spinner. The outcomes are A, P, O, and R. On the right-hand side, there is a penny. So if we flip the coin and spin the spinner, how many outcomes are possible and what are they? Well, first we're going to draw a tree diagram. The first thing we're going to do is spin the spinner. You can also flip the coin first. It doesn't change much in this case. So again, the outcomes, the 4 different letters. And then when you flip the coin, let's say you spin and you got the letter P, then from there you can have heads or tails from the coin, heads or tails with A, heads or tails with O, and heads or tails with R. So if you look at the branches at the bottom there are 8 different outcomes. PH, PT, AH, AT, H and T being heads and tails respectively, OH, OT, and RH and RT. So there are 8 different outcomes. Okay. So it says, what is the probability of spinning heads and spinning R? There's only one that matches the description. So R heads, that's just this one right here. So that's 1 outcome out of 8 that's favorable. Probability of spinning tails and spinning a vowel, so has to satisfy both those parts. let's see. Then we have A is a vowel, and then tail. So this one is good for favorable, and then O is a vowel and tails right here. So there's 2 outcomes that are favorable out of 8, which reduces to 1/4. Okay, so you can see how listing a sample space makes calculating probabilities a lot easier. Okay. So from there, let's say instead of flipping 2 coins, you're rolling 2 dice. It says use the table to list the sample space. It's already done for us here, just to save a bit of time. And there's no reason to watch me make this table, so it's going to be provided for us ahead of time. So let's see. We're going to use it to calculate some probabilities here. First one says, what is the probability of rolling 2 of the same numbers? So let's see. In this case, we have 1, 1, right? 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So that's 6 outcomes out of 6 times 6 is 36 total outcomes. And 6 of them are favorable. So let's calculate the theoretical probability using that information. Okay, so in this case, we can simply call it probability of doubles. There are 6 favorable outcomes out of 36. So that would just be 1/6. All right, next up, we have sum less than 4. So in this case, let's list what that means. Sum less than 4 means a sum of 2 or 3, because when you roll 2 dice, it is impossible to get a 1. So let's see here. Again, with a highlighter. Okay, so this makes a 2. 2 plus 1 is 3, and 1 plus 2 is also 3, and those are the only 3 outcomes that are less than 4. So you can simply write the probability as probability of sum less than 4. There are 3 outcomes that are favorable, again, out of 36, and this time it could be reduced to 1/12. All right. So here, in example 5, we're just going to think about some theoretical questions here. Number 1, what does it mean when the probability is 0? That just means there are no favorable outcomes. Right? So it's not possible to get the outcome that we want. Right? What about what does it mean when the probability is 1? That means all outcomes are favorable. So as long as the experiment is conducted, any outcome is satisfies the condition. So the event always occurs. Now, because the theoretical probability is the number of favorable outcomes divided by the total, if there's no favorable outcomes, you get 0. If every outcome is favorable, you get um, the total divided by total, which is just 1. So that means probability in decimal form or in or in fraction form is always going to be between 0 and 1. Oh, includes 1. Okay, so that just gives us some idea on what is a theoretical probability, how to calculate it, how to use the sample space in conjunction with that idea, and also some more theoretical um, probability statements like it's always going to be between 0 and 1. Okay, so that's it for today. Thank you for listening.